So with this one, we wrote out the equations as we got them. We set them up in the most advantageous way, in this case, elimination, and we solved. When we look at our next one, we're going to execute the same basic idea. I've got 27 boys and girls. I'm going to say X is my boys. I'm going to say Y is my girls. And they want us to write an equation. So I have 27 total students. X plus Y is equal to 27. There are 5 more girls than boys. So if I have my girls and I take away my boys, I'm left with 5 students. This, again, sets up super nice for elimination. You will notice, though, that this is not in the same order. So when I rewrite the equations, I'll say X plus Y is equal to 27. I'm going to rewrite my second equation so that my X's and my Y's line up. My X is negative, my Y is positive, but I want them to be in the same order as the first equation so that when I line them up, elimination happens very smoothly. I'm going to get 2Y is equal to 32, and that gives me Y is equal to 16. And if Y minus X is 5, or either one of those, I'll just use the first equation, X plus Y, which I know to be 16, is 27. Subtract that 16 from both sides, and you'll get X is equal to 11. So I have 11 boys, and I'll have 16 girls to satisfy that equation. Moving on to my next equation, number 19. Thomas sold 57 adult tickets and child tickets to his Flaming basketball team. If he charged $5 for an adult and $3 per child, how many of each ticket did he sell if he made a total of $231? So I'm going to go X for adults, and I'm going to go Y for children. I know I sold 57 total tickets. The next equation is a little bit harder. $5 times the number of adults plus $3 times the number of children is equal to the total amount of money he made. In this case, $231. What I want to do, I want to use elimination because it's so much easier. I'm going to multiply the entire equation by -3. That's going to give me negative 3x minus 3y is equal to negative 171. And then I just, eliminate. Wanted my y's to be the same, multiplied by a negative, so they cancel out. I'm going to get 2x is equal to 30, 60. So x is equal to 30. Once I know how many adults, 30 plus the number of children is equal to 57, because I know the total was 57. Pull that 30 from both sides, and I'll get the number of children at 27. Looking good. Next problem. 44 people race towards the end of the freeway. Twice as many are trying to get away from the alien monster, oh no, as there are making a break for the bomb shelter. How many people were running away from the monster? All right, now they have a very specific question we need to answer. How many people were running away from the monster? We have X, the people who are running from monster. And then we have Y, people are running towards the bomb shelter. All right, so running from the monster, running to the bomb shelter. To bomb shelter, I'll have to add that in there. We don't want them running to a bomb now, do we? So, at this point, we have 54 people. X are running away from the monster. Y are running towards the bomb shelter. And then, thank you so much. And then we're going to take and get our second equation. Twice as many are trying to get away from the monster as they are trying to get to the bomb shelter. So the ones that are running away are bigger than the ones that are running for the bomb shelter. I have to increase the ones that are running towards the bomb shelter in order for them to be equal. And here, elimination will work, but I'm going to use substitution as it's painfully obvious it's set up ready to go for that substitution. Replace X with 2Y. I'll get 3Y is equal to 54, so Y is going to be equal to 18. And then I've got, X plus 18 is equal to 54. So I pull that 18 away, and that's going to be 36. So I have 36 people running away from the alien monster, and I have 18 people running towards the bomb shelter. 21. Jeff has 82 coins. They're worth $6.10. If Jeff only has nickels and dimes, how many of each does he have? So I've got 82 total coins. I'll say X is my nickels. I'll say y is my dimes. And so x plus y, my total number of coins is 82. They're worth $6.10. This is going to be very similar to our second equation up here where we have the value of the adults, the value of the children. So I've got 5 cents times the number of nickels plus 10 cents times the number of dimes. That's going to be equal to $6.10. Now here, man, it gets a little rough if you use substitution because you've got all these decimals. And elimination is hard to figure out, but I'm going to use elimination. I'm going to multiply the bottom equation by negative 10. And what that does is it's going to line up my y's. They'll both be equal to 1. So I'll have negative 0.5x minus 1y is equal to negative 61. When I line those equations up, my y's are ready to cancel out. So I'll get 0.5x is equal, y's cancel, to 21. So x is equal, my number of nickels is equal to 42. Multiply both sides by 2. And if they add up to 82, 42 plus some number is equal to 82, that other number has to be 40 once we pull that from both sides. Again, this move right here, if you are fluent in your elimination, you can make a move like that and it makes your problem much easier to execute. Let's take number 22. Number 22. Finding, these should all be equal signs. I should have fixed that on the copy. That's my bad. By the way, 24, 25. So on 22, I'm going to do this one in maroon. We have y equal 2x minus 3. We want to know where these two lines cross. Now, very important, a lot of my students struggle with this idea. You are looking for the intersection point. And what you don't want to do is get an estimated line all over your paper and make it all ugly and such. You want to get lots of really nice points. Alright, so this is negative 4, so down 4 over 1. You want to make as many points as you can fit on the graph so that when you get that intersection, it's real nice and you can get after it. You know what I'm saying? That point's real nice. Negative 3 for y, 0 for x. That's our intersection point. On this one, set up, ready to go. I've got a plus 4 intersection point for my y. I've got a negative 2, so down 2 over 1 for my slope. Looks just like that. Here's my line. Over here, I'm going to pull my 2x from both sides. I've got negative y is equal to negative 2x plus 8. Divide everything by negative 1, and I will get y is equal to positive 2x minus 8. Now the minus 8 is going to roll a little bit off your graph down here, but it's okay. We still count up 2 over 1, up 2 over 1, and this is why you want to get a whole bunch of dots. You will notice that these two lines cross right over here at 3, negative 2, but if you only got a couple of dots, the likelihood of you hitting that accurately is lessened. So you want to make sure that you have enough dots that your graph looks good. 24. We're going to take, I'll do the y equal 4 first. Y is held constant, so we're not going up or down. We'll go straight across. And then I have my other one, y is equal to 2x minus 6. Minus 6 is my intersection, and then 2 is going to be my slope, up 2 over 1, up 2 over 1. I really got carried away with that slope of 2, didn't I? Right in this one. Anywho, looks good. We cross right there at 5, 4. And again, lots of points. You want to make sure we have lots of points to find this intersection. You don't want to cheap out on those points. Number 25. Got to solve both of these. I'll solve the one on the right first. I'm going to subtract x from both sides to isolate my y. Add the 3x. Oh, other color. Add the 3x. Really not a different color, is it? Very similar. One's maroon, one's kind of lightish purple, if you can see that. But anyway, moving along. 2y is equal to 3x minus 8. Minus 8. Divide both sides by 2. And I will get y is equal to 3 over 2x minus 4. So I'll graph that one first. Here's the minus 4, up 3 over 2, up 3 over 2, up 3 over 2. And again, get yourself as many points as you can fit neatly on this graph. It will help you with your intersection. We have a plus 6 and a minus 1 for that slope, down 1 over 1. They're going to cross really nicely for us right here at 4, 2. And that's this graph.